physical object or system. In manufacturing, digital twins are being used to simulate and optimize production processes, enabling better planning and reducing the risk of errors and downtime. By creating a virtual model of a factory or machine, manufacturers can test different scenarios and make adjustments before implementing them in the real world. Collaborative robots. Collaborative robots, also known as cobots, are designed to work alongside human workers, assisting with tasks that are either too dangerous or too repetitive for humans to perform. Unlike traditional industrial robots, cobots are smaller, more flexible, and easier to program. They are being used in various manufacturing processes, such as assembly, welding, and painting, to improve efficiency and reduce the risk of workplace injuries. Predictive maintenance. Predictive maintenance involves using data analysis and machine learning to predict when equipment is likely to fail, allowing manufacturers to schedule maintenance before a breakdown occurs. This approach can reduce downtime, extend the lifespan of equipment, and improve safety. Predictive maintenance is being used in various manufacturing processes, such as oil and gas, power generation, and transportation. Lean manufacturing. Lean manufacturing is a philosophy that aims to reduce waste and improve efficiency by eliminating non-value-added activities. It involves continuous improvement, respect for people, and a focus on customer needs. Lean manufacturing principles are being used in various industries, such as automotive, electronics, and healthcare, to improve quality, reduce costs, and increase customer satisfaction. Cloud computing. Cloud computing involves using remote servers to store, manage, and process data, enabling access from anywhere with an internet connection. In manufacturing, cloud computing is being used to store and share data, collaborate with partners and suppliers, and access software applications. Cloud computing can reduce costs, improve scalability, and increase flexibility. In conclusion, the manufacturing industry is embracing advanced technologies to improve efficiency, reduce costs, and enhance quality. From digital twins and collaborative robots to predictive maintenance, lean manufacturing, and cloud computing, these techniques are transforming the way products are made and delivered. As the industry continues to evolve, it will be interesting to see what other innovative techniques will emerge to shape the future of manufacturing. Virtual reality, VR. Virtual reality, VR, is a technology that creates a simulated environment that can be experienced through a headset or other devices. In manufacturing, VR is being used to train workers, simulate complex production processes, and design products. By using VR, manufacturers can reduce the cost of training, improve safety, and accelerate innovation. Big data analytics. Big data analytics involves using advanced algorithms and tools to analyze large and complex data sets. In manufacturing, big data analytics is being used to identify patterns, optimize production processes, and improve quality control. By analyzing data from sensors, machines, and other sources, manufacturers can gain insights that can drive innovation and improvement. Nanotechnology. Nanotechnology involves manipulating materials at the atomic and molecular level to create new products and processes.